This is a problem with a counterintuitive result, and it's about strategic anti-competitive behavior. So here we have Barnacle Industries, and they were awarded a patent over 15 years ago for their industrial strength cleaner that removes barnacles from the hulls of ships. All right, and thanks to their monopoly position, they've earned $160 million over the last decade. All right, its customers are pretty varied, but they use the product because it reduces their fuel bills. And we're given the inverse demand function, is an annual inverse demand function for their product to be P equal to 450 minus 0.0003Q. This is their inverse demand function. Their cost function is C of Q equal to 280Q. This implies that their marginal costs are equal to 280. All right, so we have their marginal cost. Now, thanks to subsidies stemming from an energy bill passed by Congress about 2 decades ago, Barnacle does not have any fixed cost. Why? Well, because the federal government pays for their plant and capital equipment required to make the energy-saving product. So this is going to be where the counterintuitive result comes in. What can they do to stave off competition from entering? One of the things we might see as a potential strategy might be to actually get rid of their subsidy, with the goal being to increase the cost of entry to their competitors. So essentially get rid of the subsidy so that way their potential competitors cannot benefit from that subsidy. And in doing so, you can increase their fixed cost of entering the market enough that they will not enter the market. All right, so that's where we're headed. All right, so absent this subsidy, Barnacle's fixed cost, they would be about $8 million annually. Knowing that the patent will soon expire, Marge, their manager, is concerned that entrants will qualify for the subsidy, enter the market, and produce a perfect substitute at an identical cost, which would clearly not be good for Barnacle's profit margins or profit. So they're considering a limit pricing strategy. Now, if you recall from the textbook, a limit pricing strategy is where you have to price low enough that you stave off or you deter any potential entrants from entering your market. Okay, so what would Barnacle's profits be if they actually pursued a limit pricing strategy in this place if the subsidy is in place? Well, if the subsidy is in place, there is zero fixed cost of entering because the government will continue to subsidize the entrance of other competitors. Therefore, to hold off or to reduce any economic incentive for other firms to enter the market, they are going to have to price such that their price is equal to marginal cost. P equal to MC, which is bad for their profit because price equal to marginal cost would be giving them a price equal to 280, and that would lead to them having an economic profit equal to 0. So 0 economic profit. So clearly that is not a good strategy for them. Okay, so what would Barnacle's profits be if Marge convinces the government to eliminate the subsidy? And here comes the counterintuitive result. So we need to think through this. What would their profits be? So first of all, we need to think, what would their profits be if they are a monopolist? All right, so think like a monopolist. All right, so if they're a monopolist, and I'll write up here, monopolist, what do? They set Q star by finding where marginal revenue equals marginal cost, and then they're going to go up to the demand curve and price high enough or just high enough to where they're charging up to what people are willing to pay based on the demand curve. All right, so in this case, what is marginal revenue? MR. Marginal revenue, well, given that we're given an inverse demand function of P equal to 450 minus 0.0003Q, we can use our handy-dandy shortcut from the textbook, where all we need to do is multiply that 0.0003 times 2, and we can use the rest of that original formula. All right, so P is equal to marginal revenue is equal to 450 minus 2 times 0.0003, so that's 0.0006Q. That's marginal revenue. If you don't like the shortcut, feel free to do the calculus. It's just the power rule from revenue going to marginal revenue. All right, so marginal revenue is equal to 450 minus 0.0006Q. So if we set MR equal to MC, that implies that 450 minus 0.0006Q is equal to the marginal cost, which in this case we found below to be 280. So once again, that marginal cost is coming from that 280 we found below. So then we simply need to solve for their quantity. All right, so that implies, if I'm just simplifying this, it's 0.0006Q is equal to 170. And that implies that Q star, if they're a monopolist, Q star M for monopoly, let me make that a prettier M, Q star M for monopoly is equal to 283 283,333.33, repeating. Now your numbers might be slightly different because this, I think, is an algorithmic problem. So your numbers might be slightly different, but the thought process is the same. All right, so what price can they charge as a monopolist? So P monop. So the price they can charge as a monopolist, well, to figure out what price they can charge, we go to the demand function. So what price can they charge? 450 minus 0.0003 times whatever quantity they are producing, which we just found. All right, so it's 450 minus 0.0003 times the quantity that they're producing, which I just found above to be 283,333.33. All right, and if I plug that into a calculator, I should get a price that they will charge as $365. All right, so the monopolist price, I'm going to highlight that in green here, is $365. All right, so given that that is the price they're charging, what would their profit be if they're monopolist? Pi monop. The monopolist profit would be equal to the price they're charging, that's PM for monopolist. So pi monop is equal to price monopolist, the price they're pulling in, times the quantity, minus 280, that's their marginal cost, times their quantity as monopolist. All right, so all those numbers we solved for above, so I'm not going to write them down again just because they're a little bit too long. But the price they're pulling in as monopolist, this term right here, that's the 365. The quantity they're selling as monopolist for me is 283,333.33. I'm going to plug it in there and there. You plug and chug those numbers into the formula, and I get, let me zoom in, I get a monopolist profit of 24,083,333.33. Right, that is going to be their monopolist profit. But that's not what this problem says. This problem says, or asks, what would their profits be if Marge convinces the government to get rid of their subsidy? Well, if she convinces them to get rid of their subsidy, then their profits are going to be that 24 million. Oh, that looks like a 9, so let me change that to a 24. 24 million. 83,333.33 minus $8 million. Because now, if the government gets rid of that subsidy, they actually have to pay that cost. Okay, so their fixed cost here is $8 million, which means that that would leave them with a profit of about 16,083,333.33. All right, so the profit's now about 16 million, which is a heck of a lot better than their economic profit in the situation where they engage in limit pricing, where to keep out any competitors at all, if that subsidy were in place, they'd have an economic profit of 0. So 16 million, certainly a lot lower than 24 million per year, but much higher than 0. But now the question is essentially counterintuitively lobbying the government to get rid of the subsidy, is that enough to do this next part of the question? Is it enough to get that entrant to not enter? So what would the profit of a new entrant be if the subsidy is eliminated and Barnacle continues to produce the monopoly level of output? And this gets to the section of the textbook that talks about residual demand. And if you're just following along the textbook, you might want to just note that, let me see, it's so in the textbook, you can see this, let me write this down, figure M1-2. Figure M1-2 in the textbook. It goes over limit pricing and residual demand. That's essentially following along with what we're doing here, the general idea. All right, so that's in the textbook. Now, what we need to know intuitively is that this is a potential entrant, and what they're seeing is that there is an incumbent monopolist that already exists in the market. That incumbent monopolist is currently charging a monopolist price of $365. Therefore, this potential entrant needs to think, hey, if we come in and we charge a price higher than the current price at $365, we're not going to sell anything. Like, we are soaking up, we're getting the residual demand. So if we come in and we try to charge a price higher than $365, we sell nothing. Nope, we can only sell if we charge a price below $365. And this is following along with that residual demand section of the textbook. So here at D, residual, or you can think of the residual demand. Well, if you think about it in terms of that inverse demand function, which here is given as 450 minus 0.0003Q, think back to what I just said. They sell nothing if they charge a price above 365. They only sell if they go below 365. So their demand function actually starts not at 450, it starts at 365. They have to price under the incumbent monopolist to sell anything. All right, so the residual demand for them starts at 365, P equal to 365 minus 0.0003 Q. So the slope is still the same. All right, and now from their perspective, they are also going to set marginal revenue equal to marginal cost. And in this case, what does that imply? Well, we're going to use once again, our shortcut rule. Marginal revenue, in this case, is equal to 365 minus 0.0006 Q. Once again, that shortcut is taking the inverted demand function, using the intercept, same thing, 365 to 365, and then you subtract off whatever this number is here, multiplied by 2, so that's 0.003 times 2, that is 0.0006. All right, so that's their marginal revenue. We see that they set that equal to their marginal cost. And what is their marginal cost? Their marginal cost is 280, because here we're assuming that they have identical marginal cost to the incumbent firm. So if I just solve for quantity, how much are they going to produce? That's 0.0006 Q is equal to 85. And that implies that if this firm were to enter, the optimal quantity that they should produce for my numbers is 141,666.66, repeating. Now, what does this do to the market? Well, the overall price in the market is going to change if they were to enter. They can't just continue to charge that monopolist price, because now they're going to saturate that market, which is going to bring down the price in the market because they are supplying excess quantity to the market. That's going to bring down the overall market price. So what is the overall market price? P market, if they were to enter. P market. Well, for that, we need to go up to that overall inverted demand function. P is equal to 450 minus 0.0003 Q. And now for Q, we're going to account for the quantity from both the incumbent monopolist and them if they were to enter and saturate that market. So price in the market is 450 minus 0.0003 times overall quantity of the market. And quantity of the market is 283,333.33 from the incumbent monopolist. We found that above. That's up here. Oh, sorry, that is up right here. Let me go there. Plus the 141,000 that the potential entrant would actually produce themselves. So plus 141,666.66, which is equal to 322.5. All right, so if they were to enter the market, overall price in the market would drop to 322.5, which means that their profits as an entrant, pi entrant, the profits of the potential entrant would be the $322.5 per unit that they're pulling in, minus their marginal cost of 280 times the 141,666.66 units that they're selling. But then you need to subtract off that $8 million. And that's because if and above, Marge and the Barnacle Company are successfully able to convince the company to get rid of that original subsidy that existed for the last 15 years, that means that this potential entrant would have to pay the fixed cost of entry. They would have to in order to enter the market, they'd have to pay for the plant and capital equipment required to actually make the product. And therefore, that fixed cost would apply to them. And now if I just plug and chug that into a calculator, or if you do that, you should get a different number if it's an algorithmic problem with different numbers. I get a profit of negative 1,979,166.95. Or in a nutshell, what happened by having Barnacle Company or Marge lobby the government to actually get rid of the subsidy that existed for the last 15 years, this increases the entry cost of a potential entrant to the extent that their profits would actually be negative. Therefore, lobbying the government to eliminate the subsidy is actually good for the profits of the Barnacle Company because it staves off any potential competition from entering. And this does it much more effectively for their profit than a limit pricing strategy. And just to reiterate everything that was already discussed at the front of Module A in the textbook, This is anti-competitive behavior. I'm not recommending that you and your company do this. This is just something that you should be aware of in terms of the anti-competitive landscape and strategic interaction of firms. Some of this stuff is legal, some of it is illegal, some of it is in a gray area. Whether or not you do it with your firm is different from whether or not it's actually happening already in other firms in various industries. Something that you should be aware of.